All right, so in 8.4 we talked about binomial expansion, right? So we talked about how to find the individual coefficient, which is like number 1, how to expand it like number 2, how to do the Pascal's triangle, and then how to find a specific term. So the one formula that you needed to know for this section was that C and R, which is n factorial over n minus r factorial times r factorial. So if you're keeping track, that's the 6th formula in the chapter that you need to know. So with number 1, it says find each binomial coefficient. Your n is on the left, your r is on the right. So this would be 8 factorial over 8 minus 3 factorial times 3 factorial, or 8, this would be 5 factorial, 8 times 7 times 6 times 5 factorial over 5 factorial, and then 3 times 2 times 1. The 5 factorials are going to cancel out. 2 goes into 6 3 times, and then 3 and 3 cancel, and I get 8 times 7, which is 56. That would be the binomial coefficient. If it was something raised to the 8th power and you were looking for the 4th term, okay, you would use it. Number 2 says write the expansion of the expression. So for each of these, you're going to set up your terms based on n. So n is your exponent. This is 3. Which means I'm going to start with the exponent being 3 on the first one, work its way down to 0, and then the reverse for the second term. And you should also know from there that it should be 4 terms at the end. So I would do 2, I'm going to leave a space because I'm going to fill in with my leading coefficient. 2x raised to the 3rd, and then it would be negative 3y raised to the 0, but I'm going to leave it off because we don't need it. Then it would be 2x raised to the 2nd, and negative 3y raised to the 1st. Then it would be 2x raised to the 1st, negative 3y raised to the 2nd. And then you finish it off with 2x to the 0, so I don't need it, and negative 3y to the 3rd. Then you can actually, I'm going to skip to number 3 and then come back to it, because number 3 said to write the 6 lines of Pascal's triangle, right? So if that would be 1 and 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 5, oops, sorry, 10, 10, 5, 1. So if you're counting rows, that's 1, 2, 3, 4, 5, 6 rows. That would be 6 rows of Pascal's triangle. However, if I said to give me the 6th row, remember that I'd have to go one more than that because that first row is called the 0 row. So if I have the n is 3, the easiest way to find the row you need to use is look at the second number in this diagonal, right, after what follows 1, which if I'm looking for the 3, then I'm looking for this row, which is 1, 3, 3, 1. So I can multiply that in, or I could have found my binomial coefficients for each one. It would have been C, 3, 0, C, 3, 1, C, 3, 2, and C, 3, 3. Honestly, for the binomial coefficient, for the binomial expansion when you're going all the way out, I think it's easier to use Pascal's. And you're going to be asked to do it on your test anyways, okay? For the next one, I'll show you how I would do it without it. All right, so now I got to multiply out each of these individual terms. So there's a term there, and a term there. So the first one is 2x to the 3rd. That would be 8x to the 3rd times 1, so 8x to the 3rd. This would be 2x to the 2nd, which is 4x squared. That's a 1 on the outside, times negative 3y times 3. So 3 times 4 is 12. 12 times negative 3 is negative 36. And then x squared y to the 1st. Then I go to the next term. This time I'm squaring negative 3y, so that's 9y squared. 3 times 2 is 6. 6 times 9 is positive 54. X to the 1st, y to the 2nd. And then the last one, negative 3y to the 3rd, would be negative 27y to the 3rd times a positive 1, which is negative 27y to the 3rd. That's your expansion of your expression. Questions so far? So I answered number 3 on the first one, okay? And then number 4 says find the 6th term of 3a plus b to the 7th. So I want to find n, which is the highest exponent, the exponent, not highest exponent, the exponent on the expansion, which is 7. And then if I'm looking for the 6th term, what is r? 5, one less. So then it is C, N, R, and then I would raise the first term to the N minus R, and then I would raise the second term to the R. So this is C, 7, 5, 3A, 7 minus 5, and B, 5. So 7 over 5, or sorry, over 7 minus 5, which is 2 times 5. 7 times 6 times 5 factorial over 2 times 1 times 5 factorial. This cancels. 2 goes into 6. 3 times this is 21. This would be raised to the second power. That would be 9a squared and b to the 5th. And then 21 times 9 is 189a squared b to the 5th. Questions on any of the binomial theorem stuff? All right, so we're going to start 8.5 today. This is called Counting Principles. It's kind of a long section, so we'll finish it out tomorrow. Okay, but it's our introduction into probability. So within 8.5 and 8.6, you're going to get a lot of probability. That's where the chapter will end. Test will be on 8.1 to 8.6 next Friday, so a week from tomorrow. So the counting principle, okay, starts with simple counting problems. So these are ones in which if you're looking for the probability that a simple event occurs, you would put the number of what you're looking for over the total amount of items in the set. So basic, if it said that there was a box full of green and red rocks, what are the probability that you're going to pull a green rock, something like that, it would be the number of green rocks over the total amount of rocks in the box. Okay, same thing with socks or numbers or roll of the dice. All that stuff would be simple probability, okay, or simple counting problems. And for those, if it asks you for the probability, you're going to give it in terms of a fraction, and you'll always simplify it, okay? There's something called replacement and non-replacement. So if a random selection is with a fresh set every time, that would be called with replacement. So if I take a rock out, but then when I'm done, I put it back. I have a fresh set of rocks, that would be with replacement. Rolling a dice is going to be like with replacement because you can't remove a side of a die. Flipping a coin would be something like with replacement because you're not going to be losing. Like once you flip a heads, it doesn't go away. And then random selection that is removed after a choice is made is referred to without replacement. So if I put a box at the front of the room with a bunch of rocks and I asked Sarah to go up and grab a rock out, there would now be one less rock for the next person to pull from. That would be without replacement. So one of the hardest things when you get into probability is reading and figuring out what the heck it's asking for. You got to pay attention to things like with replacement and without replacement. Yeah? You sure? Yeah, okay. So example 1 says determine the number of ways in which a computer can randomly generate one or more such integers or pairs of integers from 1 through 15. So in a random generation, you're not going to keep the number. Like once you take out a number, it's not gone. So this is a situation in which there would be replacement, if you think about it that way. So if you think about the numbers between 1 through 15, so you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And A says, what are the chances, what are the number of ways, so you're just looking for a number, in which a computer can generate an odd integer. So from 1 through 15, I want to just count my odd integers. Okay, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 odd integers. If it asks what's the chances of pulling the odd integer, then that 8 would go over the 15, okay, and then get reduced if it can. B says an integer that's divisible by 4. So what numbers from that set of 1 through 15 are divisible by 4? 4, 8, 12. How many numbers are there? 3. Easy stuff, right? So you're just building the set. Example 2 says 8 pieces of paper are numbered from 1 to 8 and placed in a box. That should be 1 piece of paper is drawn from the box. Its number is written down and the piece of paper is returned to the box. Then a second piece of paper is drawn from the box and its number is written down. So I've got a little piece of paper with a 1, a 2, a 3, a 4, a 5, a 6, a 7, and an 8. The two numbers are added together. In how many different ways can a sum of 12 be obtained? Okay, so think about it. If I pull a 1 the first time, is there a number I can add to 1 that's going to give me 12? No. How about 2? Nope. 3? Nope. 4? Yes. So if I pull a 4 the first time, what would I have to pull the second time? An 8. How about if I pull a 5 the first time? How about if I pull a 6? So this is where the wording is so important. And I italicized it, but it won't always be like that. What does it mean if it's returned to the box? Then I can count 6 and 6, right? If I took 6 out, but I put it back in, I can pull 6 again, so this would actually count. Now, I said it before, but it's part of it. The hardest is the wording on this. So what happens if I pull an 8 the first time? I can pull a 4. Is that a different way to get 12? Yep, so it counts. So then I can also say 8 and 4. How about if I pull 7 and 5? That would be different. If I pull 6 and 6, is it different? No, it's the same, which means how many ways in which can 12 be obtained? 5. I need the sum to be 12.
And every time you have to write it down or something like that?
No. I mean, you. For me, it's easier to identify it that way. There's no, for these kind of problems, it's not like there's a shortcut or a formula or anything like that. No, we'll learn that in a minute, but not for trying to figure out how many. Yeah. Okay, example 3 says 8 pieces of paper are numbered from 1 to 8 and placed in a box. 1 piece of paper is drawn from the box, its number is written down, and the piece of paper is not returned to the box. Then a second piece of paper is drawn. The two numbers are added together. How many different ways can the sum of 12 be obtained? So what changed other than apparently I caught my typo on this one and not on the last one? Not returned, which means you can't use 6 and 6. How many choices are there now? 4. So you can still use 4 and 8, 8 and 4, 5 and 7, 7 and 5, but you can't use 6 and 6. And again, these words are italicized and bolded right now, but they will not stay that way, so you have to be very careful in reading your instructions. Natalie?
So how is it like 4? Because if you take out like the 4 and 8 and it's not returned, then wouldn't it be like less? Like you can't do it again?
So you're not saying how many, like from the same set, you're saying how many different ways can it be done. So if I put it at the front of the room a box with all of those numbers, and I asked you to go up to the box, you could pick a 4 and an 8. That would count as 12, right? Whether you put it back or not in between your turns impacts what options you can make. But we're saying if I sent somebody else up there a different time, you could also pull 6 and 6 if you put it back, but not if you don't put it back. But it's not saying you can do all of those things, because without replacement that wouldn't work. It's which ways can they be done? Does that make sense?
Yeah.
Okay. All right, so the fundamental counting principle says that E1 and E2 are 2 events. The first event, E1, can occur M1 different ways. After event 1 has occurred, E2 can occur M2 different ways. The number of ways that events can occur is M1 times M2. Okay? So what this means is there are 2 separate events that are not related to each other. The set from one has nothing to do with the set from the other. Okay, these questions come into play like you're going to a sandwich shop. You can pick bread, you can pick meat, you can pick cheese, whatever it is, toasted or not toasted. And it says how many combinations would there be? So it's how many number of choices of bread, how many number of choices of meat, how many number of choices of, what did I say before, cheese, and how many, is it toasted or not toasted, how many options there are, and you just multiply them all out together, okay? This is, some people have the choice between 5 shirts and 4 pairs of pants. How many outfits can there be? And it would be the number of shirts times the number of pants, okay? This could be a box of rocks and a box of numbers. How many rocks are in one box? How many different numbers are in the other one? These are separate events, and the way you figure out the number of ways they can be chosen is just multiplying the number of options in each set together. So this says how many different pairs of letters from the English alphabet are present. So I want to pull one letter from the English alphabet. How many choices do I have? 26. Now I want to pull another letter from the English alphabet. How many letters are there? 26. This is different than if I said I put a letter of each letter on a piece of paper in a box. Somebody went up, picked one out, kept it. Now the next person goes up and picks one out, right? That's kept. That would be without replacement. Now my second number is what? 25. Does that make sense? Okay. So this would be 26 times 26, which is 676. Because you're saying like what that letter, so different pairs means it can be A and B, it can be A and A, it can be A and C, right? So there's 26 choices for the first letter and there's 26 choices for the second letter. If it said they couldn't repeat, now it's 26 times 25. Does that make sense? Because A can't go with A, but A can go with B and C and D and D, and then B can go with them.
Yeah, so then would it still be 26?
No. If it says it can't repeat, it's like you've taken it out. It's gone, so it's not with replacement. So now your bank changes from 26 options to 25 options. Number 5 says a combination lock will open when the right choice of 3 numbers from 1 to 30 inclusive is selected. How many different lock combinations are possible? What does inclusive mean? It includes 30. So from 1 to 30, how many numbers is that? 30, right? We should know that now because of our 1 to n, right? 1 to 30 is 30 numbers, and it says that there are 3 numbers for this lock. So how many choices do I have for my first number? 30. How many numbers do I have for my second number?
20.
Did it say they can't repeat? No, so 30. How many do I have for my third number? 30. So if it said they couldn't repeat, now it would switch from 30 to 29 to 28. Does that make sense? Okay, so that's 3 times 3 times 2. That's 27, and then 1, 2, 3 zeros. Questions so far? All right, example 6 says, in a certain state, each license plate number consists of 2 letters followed by a 4-digit number. How many distinct license plate numbers can be formed? So the first is the letters. So letter, and then a 4-digit number. Number. How many letters do you have to choose from the first time? 26. How many letters do you have to choose from the second time? 26. Didn't say anything about it not being able to repeat, right? How many 1-digit numbers are there? You're right. It's 10. Because 0 would be a 1-digit number. Okay? So this would be 10, this would be 10, this would be 10, and this would be 10. So we know 26 times 26 is 676. 1, 2, 3, 4 zeros.
So you're saying the 2 letters can be 26 different things you can do letters?
Yes. 26 times 26.
I mean, like, since I thought, like...
So separate them out. If it's 2 letters, it's 2 different instances. Letter 1 has 26 choices. Letter 2 has 26 choices. If in that problem it said the letters can't repeat, now that first blank is 26, but the second blank is 25.
Yeah, because that, like, you can do A with B, A with C.
Correct.
But then you can do
B with A.
And then you keep going, but
Yep.
I thought it would be more than 26.
No.
Oh, okay, I think we get it now. Because, like, you're just picking one, you're not picking all of them together. So you have 26.
You have 26 that can go with 26. So you have the first one that can go with all 26. You have the second one that can go with all 26. You have the third one that can go all like that.
It says like 4-digit number. I don't get that. Like,
So the number 0 to 9 is a single digit number, right?
yeah.
So don't think about it in terms of its entirety. Don't think about it as a 2 letters, and don't think about it as 4-digit. Think about separating it out, right? If it's 4-digit numbers, that means there's 4 spaces to fill, and each space is filled with a single digit number, which goes from 0 all the way up to 9.
And that's 10.
And that's 10. Yep. So sometimes you'll see things like the leading number can't be 0. Now your set just went from 10 to 9. That's how they would alter. Or the last digit can't be 1. You've just eliminated an option from the last digit. Does that make sense? Okay. All right, permutations are determining the number of ways that n elements can be arranged in an order. So probably the most important word here is in an order. And how many ways can something be put in order? To do that, you do the number of permutations is n factorial. So if you let's say fast forward to Tuesday, you guys are getting new seats Tuesday. Let's say I lined you all up at the front of the room, okay? And I only had exactly the amount of seats as I had people. So I don't know, let's say there's 23 of you. And I line the 23 of you up and I have 23 seats available. And I let person one choose their seat. How many options do they have? 23. Now they're sitting in that seat. Second person goes. How many options do they have? 22. Then 21. Then 20. Think about what you're saying, right? 23 factorial, basically, yeah? So if the order matters, and that's important because that's the difference between accounting, just multiplying it out, or saying order matters, that's when it's a permutation. So things like how many ways can somebody finish in a race? That's order matters, that's permutation. How many ways can you be arranged in a car? How many ways can you be arranged in a seat? All that stuff is permutation, and that is factorial. So if it was how many ways can 10 objects be put in order, it would be 10 factorial. If it says, find the number of permutations of the following letters, obviously if the word permutations is there, you already know, okay? It's in order. How many letters are there? 6. So this is 6 factorial. 6 times 5 times 4 times 3 times 2 times 1. 30. 120. 360. 720. Keep in mind your test is going to have 2 parts with a calculator and without a calculator. If I ask you to do a permutation that has like 20 items, I'm going to give you a calculator. Okay, I don't want you to do 20 times 19 times 8. But 6, you could do that.
So it's gonna be like the test is one section is gonna have a calculator.
Yep.
And like is it like a scientific or a graphic?
Like you can use either one.
Okay.
Yep.
And then for the other one, no calculator.
Correct. All right, permutations taking a certain number of elements at a time. So this is a scenario in which maybe you have 12 runners running a race, and you want to know how many different orders there would be for first, second, and third place. So you're taking a number of people at a time, okay? If you pull out five racers, that kind of thing, okay? So if it's at a certain elements at a time, you're going to have 2 pieces of information. 1, the total amount of elements. 2, the certain amount of elements at a time. And so for that, it is NPR. So this is a permutation with N and R. This looks very similar to C. Remember, C is N factorial over N minus R factorial times R factorial. So the only difference between P and C is that you don't add on the R factorial. If you remember your calculator menu when we went in there yesterday, on the probability menu, there was an NPR and an NCR. So permutations taken at an element at a time is the NPR. Those look like this. Find the number of permutations of 8 horses taken 3 at a time. So you have 8 horses, but you only want to figure out what kind of order I can put 3 of them in at a time. If it was all 8, it'd be 8 factorial, but this is take 3 at a time. My N is 8. My R is 3. So this would be 3, 8. I'm sorry, P with 8, 3. So this is 8 factorial over 8 minus 3 factorial. 8 times 7 times 6 times 5 factorial. So 8 factorial over 5 factorial. The 5s cancel, and I get 8 times 7 times 6. Questions on that one? Okay, or you'll see it written just like this, and it would be 6 over 6 minus 2, which is 4. This is 6 times 5 times 4 over 4. That's 30. So a question like that, obviously expect on the non-calculator portion.